Chapter 14, Section 6, in the 8th grade note-taking guide, is entitled Multiplying Binomials Together. So as you know, binomials are two-term polynomials, meaning they're going to be separated by only one, addition or subtraction sign. So the process of multiplying binomials is done by a process known as FOIL. That's the most common. There are some others. I'll show you one of the others that you might have some success with as well. But FOIL is an acronym for the terms used in multiplying two binomials, standing for first, inners, outers, and lasts. The F in FOIL is first, the O in FOIL is outers, the I in FOIL is inners, and the L in FOIL is last. That describes the 4 different multiplications you have to do in order to successfully multiply together two binomials. Now that can actually be a tricky process. So what you will see we will do is we will also introduce this as a table method that does the same multiplications but shows that work in a different order. So let's go ahead and take a look at 1a. We've got the binomial n minus 2 being multiplied with the binomial m minus 8. So the good thing we can do first here is identify our f, the o, the I, and the l, because we need to know what those things are. F stands for the first. So when we're talking about the first, what we mean here is the first term in each binomial. So in this problem, that's the n and the m. All right, and we're going to multiply those together, and that's going to get dragged down into our solution. Then we've got the O. The O stands for the outers, the outside terms in the expression. So that's going to be this n here and the 8 here. They're furthest on the outside of what I've written here. And those are going to get multiplied together and get dragged into the expression. I stands for the inside terms. So that's what's inside our polynomials here, what's inside what we've written here. That's our 2 and our m, and again, we're going to take the signs in with them. And L stands for the last. That's the last term in each binomial. So that's my 2 and my 8, which are also going to have to get multiplied together. We'll drag that down into the answer. Now there is potentially some like terms that could be derived then when you multiply all that stuff together. And then you would have to combine those like terms because those are all going to be connected, each term that you figured out, with addition or subtraction. This is one of those sections where it's most helpful to take the time to change subtraction into adding the opposite, because then we know we'll have some negative signs, but everything's going to be hooked together with an addition. So that's exactly what I'm prepared to do here. I'm going to change this into n plus negative 2 being multiplied by m plus negative 8. I changed both of these subtraction signs into adding the opposite, the same way when we learned about subtracting integers, what we would do based on those rules. All right, so F stands for the first. I'm going to multiply the first terms together here. That's my n and my m. Well, that's a nice multiplication, so we just have to put those together, and that's going to give me nm or mn, whatever you want to say. As you can see in their solution, they've written mn. Then I'm going to go grab the o's, the outside terms here. That's my n and my negative 8. Well, I'm going to run those together, and that's going to give me negative 8n. Then I'm going to grab my inside terms, what's inside the expression that's been written here. Well, that's my negative 2 and my m, and I'm going to multiply those together, and that's going to give me negative 2m. And then I'm going to get my last terms, the last term in each binomial, negative 2 and negative 8 combined to make positive 16. So I write plus 16 there. And as you can see, my answer looks a little bit different than the answer that was pre-printed. Again, the reasoning is we got rid of the subtraction so we don't make a sign mistake. Here you can see they wrote minus 8n. Here instead we wrote plus negative 8n. Here they wrote minus 2m. Instead they wrote plus negative 2m. But it's the same thing. You know that 3 minus 4 would be the same as 3 plus negative 4. And that's exactly what they've done. And that's the process known as FOIL. It's me taking every term and multiplying it by every other term. Now you're saying, oh, that's a lot of work. Yes, indeed, it was a lot of work. We do have a potential helper here in the form of a table method.
The table method will still do FOIL for us. It will still do the steps of FOIL, but it does it in a different way. Let's try that in B here. X plus 3 times X plus Z. Now, one of the things you would do with the table method, just like when we did FOIL in 1A there, is you would go ahead and change subtraction into adding the opposite. All right, as you can see, these are both addition, though, so we don't have to worry about it. So we're going to go ahead and sketch ourselves a little table here, and you're going to make, kind of like you're making a Punnett square in science, you're going to chop it up into 4 even blocks. Across the top, you want to go ahead and list your one polynomial, x and 3. And down the sides, you want to list your other polynomial, x and z. And as you can see, I'm totally leaving the plus signs out because that's the point of changing subtraction into adding the opposite. I know that when I put all this together, once I've done that step, that I'm just going to stick addition signs in between everything. So as long as you've done that step, you don't have to worry about signs. If you don't do that step, you're going to have quite a mess on your hands when you have to go back and recreate this. Table. Each box is simply the product of what's above it and what's to the left of it. So for instance, this upper left box Here has X above it and X to the left of it. So I'm supposed to multiply together X and X. Well, you know from the product of powers rule, when I multiply together problems with the same base, or multiply together powers with the same base, I add the exponents. That's going to give me X squared. In this box here, I have 3 above it and X to the left of it. So I just run those together, and that's going to give me 3X. In this box here, I have X above it and Z to the left of it, so I'm going to combine those, and that's going to give me XZ. And in the final lower right box there, I have 3 above it and Z to the left of it. I combine those, and that's going to give me 3Z. And all I'm going to do now is combine these all with addition signs. So I've got X squared plus XZ, which is here, plus 3X, which is here, plus 3Z, which is there. And as you can see, my answer from the table method matches exactly what they did in the FOIL process. Again, it doesn't matter which method you like. You can do either one. The solution is the same regardless of what you choose.